everyone, and welcome to today's webinar, Navigating the Molecular Frontier, From Poo to Precision, a Journey in GI Test Implementation. I'm Christina Jewell of LabRoots, and I'll be your moderator for today's event. Today's educational web seminar is presented by LabRoots and brought to you by Thermo Fisher Scientific. To learn more about our sponsor, please visit thermofisher.com. Now, we encourage you to participate today by submitting any questions you have during the presentation. To do so, simply type them into the Ask a Question box and click Submit. We will answer as many of your questions as we have time for at the end of the presentation. Also, if you experience any technical questions, you can utilize this Q&A box and we will assist you directly. I would now like to welcome our speaker, Rachel Alexander, Technical Product Manager for Physicians Group Laboratories and Providers Choice Laboratory. For a complete biography on our speaker, please visit the Biography tab at the top of your screen. Rachel, welcome. You may now begin your presentation.
Hi, welcome everyone. Today I am pleased to share some insights into the decision-making process and strategic considerations surrounding building a PCR test from the ground up, specifically focusing on gastrointestinal panels. We will delve into the journey of GI implementation in our laboratory and discuss how we addressed challenges, found success, and enhanced our testing menu to align with client requests and new regulatory trends. This presentation is for educational purposes only. Opinions or viewpoints expressed by myself do not necessarily represent the official position or policies of Physicians Group Laboratories or Providers Choice Laboratory. Also, please take a moment to read this disclaimer. I would like to emphasize that Thermo Fisher Scientific products in this presentation are for research use only, not for use in diagnostic procedures. Thermo Fisher Scientific and its affiliates are not endorsing, recommending, or promoting the use or application of their products presented today. Any adaptations by PGL and PCL are of our sole responsibility. Let's begin by talking about the evolving landscape in molecular diagnostics. The emergence of the COVID-19 pandemic drove molecular technology to the forefront of diagnostics, leading to a significant surge in respiratory testing and the rapid establishment of new laboratories worldwide. With the urgent need for efficient and accurate testing, polymerase chain reaction, or PCR, emerged as the go-to platform, offering fast and sensitive detection of the SARS-CoV-2 virus. However, with the pandemic waning, now there is a notable shift towards leveraging PCR to address a broader range of healthcare needs. PCR's versatility extends beyond respiratory testing, playing a vital role in diagnosing infectious diseases, detecting genetic disorders, and even monitoring cancer progression. Its accuracy in amplifying and analyzing specific DNA or RNA sequences enables precise identification of pathogens, genetic variants, and biomarkers, resulting in personalized treatment strategies and improved outcomes across a wide range of healthcare applications and scientific research. We also see that market dynamics are shifting with the decline in demand for respiratory testing, prompting companies to reassess their strategies. Companies unwilling to adapt may face stagnation, while others can seize opportunities by pivoting towards emerging areas like the gastrointestinal field. The GI diagnostics market is projected to reach $2.5 billion by the end of 2024, and has experienced a compound average growth rate of around 9% since 2021, illustrating the interest in and importance of GI testing. Traditional methods of GI testing for infectious disease have been relied upon for years. However, molecular testing stands out by consolidating data from several traditional methods into one comprehensive test. Let's discuss some of the basic differences. Testing begins by collecting a stool sample in a sterile container. When performing stool cultures, a fresh fecal sample is recommended to reach the lab within 2 hours of collection to preserve microbial integrity and reduce the risk of false negative results. It is possible to store the sample by refrigeration or freezing. However, this could limit the types of traditional tests to be performed. The PCR method typically requires less sample volume, which can enhance comfort during sample collection, and samples can be kept at room temperature or refrigerated for days without the concern of genetic material degradation, especially when housed in a transport media. Stool culture also requires highly controlled temperature and environmental conditions, since it focuses on growing live microorganisms. This method is also limited by the time it takes for organisms to grow. While common pathogens like Salmonella grow within 24 to 48 hours, many other species require over 72 hours for growth. Additionally, parasitic and viral pathogens cannot be cultured at all and requires additional testing methods. Technicians are able to determine pathogens by visual observation and identification through microscopes, and also through biochemical tests. PCR, however, does not have the same constraints, as detection is based on gene-specific amplification and does not require the organisms to be alive. Results are also available within hours of processing, which is a large advantage to this method. PCR has already emerged as the gold standard for norovirus testing, and literature from the CDC and NIH anticipates that PCR testing will quickly dominate the new era of GI diagnostics. This is likely due to its ability to detect multiple species of microorganisms within one sample. And it can also successfully identify hard-to-culture species like Campylobacter, Yersinia, and viruses. It can differentiate between strains of bacteria without adding additional testing methods. This is important in species like E. coli, which have multiple strains, some of which are toxigenic. And lastly, traditional methods are largely manual procedures, while PCR is highly automated, reducing error and contamination risk, and offers a high throughput option while producing precise data. So now that we have some background, how do we begin developing a molecular test? Well, one, who and what is this test designed for? Well, PCR can serve multiple purposes depending on the application. So understanding your client base is the first step in development. Next, we want to identify the purpose in testing in order to effectively cater to a desired market. For instance, applications in healthcare would aim to provide quick and accurate pathogen identification, whereas research-based testing may not have the same time constraints or client-facing interactions, but it is beneficial for medical literature and improving overall testing practices. Each market will have specific needs to consider when building a test, and today I will be discussing clinical diagnostics in an educational capacity. Our second question to consider is, what are the appropriate targets or assays to include on your test? Well, determining the right targets to include on a PCR testing menu is incredibly important for a company's success. One way to do this is by understanding different healthcare settings within your region. Would you like to focus on family practice? If so, your test may cover a wide range of pathogens which are found in GI infection across all age groups. Starting with a comprehensive test panel that includes common bacterial, parasitic, and viral pathogens could be an appropriate approach. Or, Are your clients primarily geriatric or in long-term care facilities? You may consider prioritizing pathogens such as C. diff, which are more commonly acquired during hospital stays or among individuals with a weakened immunity. Alternatively, a pediatric specialty panel could emphasize pathogens like rotavirus and sapovirus, which are particularly prevalent among young children. And third, what additional trends or metrics should be considered? Well, GI testing also has a seasonality component, which can assist your company in effectively allocating resources to anticipate changes in testing volume. For instance, norovirus infections, commonly known as the stomach flu, often peak during the winter due to indoor crowding, holiday gatherings, and travel, which can easily facilitate the spread of this virus. Rotavirus, a leading cause of severe diarrhea in infants and children, rises in the fall, as infection is often linked to daycare and school settings. But foodborne illnesses such as Salmonella and Campylobacter trend upwards in the summer months due to increased consumption of contaminated foods like undercooked poultry or warm dairy items that are eaten at picnics and barbecues. You may also see higher cryptosporidium rates in the summer due to increased water recreational activities. So by considering pathogen seasonality and monitoring detection rates, your laboratory could plan for variances in testing volume. This information could also assist with preventative measures by educating clients on transmission potential and contribute to outbreak surveillance for public health benefit. Now that we have selected a market and have a general idea of our pathogens of interest, how can we enhance our test strategic value? The answer lies in the arrangement of assays within either a syndromic or focused panel framework. Syndromic testing means broad screening of pathogens based on clinical symptoms, which is a common approach in GI testing given the similarity of symptoms such as nausea, vomiting, and diarrhea. While selecting syndromic panels for GI testing, you might include tests for common pathogens such as Salmonella, norovirus, and various strains of E. coli. These pathogens are known to cause a range of gastrointestinal symptoms, making broad screening essential for accurate diagnosis. While syndromic tests are important for comprehensive coverage, the client may not find that all pathogens included on the panel are medically necessary in some cases. A different strategy could be to create focus panels. These panels could target specific pathogens that may be more relevant to a client's needs. If taking into consideration additional demographics, such as lifestyle and age, in addition to their clinical symptoms. For instance, a focus panel may only include parasitic targets such as Giardia, Cryptosporidium, and E. histolytica, and could be especially appropriate if the individual has prolonged diarrhea or has recently traveled. Additionally, you may want to look at special consideration targets. My company's laboratories are in the Gulf Coast region, so a special consideration target could be to add Vibrio vulnificus to the panel, as it is known to cause illness from contaminated raw oysters, which many people enjoy eating in this region. Here are two scenarios to illustrate applications of both panel types. First, we have Monica, a 28-year-old female, who arrives at an urgent care clinic with complaints of severe abdominal pain, prolonged diarrhea, vomiting, and resulting dehydration over the past 5 days. She has recently returned from a vacation to South America. She did her best to only drink bottled water and to be mindful of potential sanitation issues. However, Monica could not resist trying a local taco cart, even after seeing raw meat being stored closely to her other food items. The physician also notes that there is a high possibility of foodborne illness, but that the area that Monica was visiting is also known for norovirus outbreaks. Due to the severity of her symptoms, her physician suspects that she may be infected with multiple pathogens. He orders a comprehensive panel to capture parasite, virus, and foodborne bacteria. In this case, Monica has been infected with both norovirus and salmonella. Now let's look at Ross, a 40-year-old male who recently began a diet of which he regularly consumes salad greens from a local deli throughout the week. Much to his dismay, he has not experienced much weight loss over the past 2 weeks, but has been experiencing bloating, nausea, fever, and sporadic bouts of watery diarrhea. His physician orders a focused foodborne panel in order to determine the cause of the infection due to his recent change in lifestyle. In this instance, Ross has been infected with Listeria monocytogenes, a pathogen which is frequently found on fruits and vegetables. The recent ruling by the FDA on laboratory-developed tests, coupled with MALDI-X and new coverage determination by insurance payers, highlights the significance of regulatory impact on testing. This alignment has resulted in a recent divergence in coverage for nucleic acid amplification tests like PCR. We now see an increasing trend towards reduced coverage for GI syndromic or comprehensive testing, which are considered to be particularly large panels of 12 or more targets. However, focused panels with 11 or less targets may present a cost-effective alternative by honing in on specific pathogens, potentially leading to improved reimbursement rates and less financial strain on healthcare providers and patients. Additionally, focused panels may offer clinicians more control over targets and selection based on medical necessity, which could contribute to antimicrobial stewardship by minimizing unnecessary treatment. Focused panels may also eliminate the need for dual diagnosis codes and allow testing for a broader patient population, as small panels require less stringent conditions to be met for testing. As you can see in this table, there are several conditions which still need to be met to determine either category of testing. The comprehensive panels are mostly restricted to those with immunocompromised conditions. As the medical coverage space is very complex, checking cms.gov may be a great starting point when determining GI testing guidelines for your panel. Another resource can be found at the American Medical Association webpage. The fee schedule provided by the AMA outlines reimbursement rates for medical services and guides billing practices within the healthcare industry. Physicians and healthcare providers often refer to the AMA fee schedule to determine appropriate charges for their services and to ensure fair compensation for their expertise. Now, this is not coding advice, but here are some examples of codes found in the current 2024 AMA schedule in relation to GI testing. As you can see, there are panel-based codes depending on the number of targets, but there are some pathogen codes that have specific codes as well. Of course, these items are subject to change, so it is important to work closely with your company's compliance and legal teams, revenue cycle management, coding specialists, and also check the payer guidance to establish correct medical billing for all of your new tests. With these items in mind, a new GI test will be able to retain profitability, maintain compliance, and remain accessible in the market. Developing a molecular test also involves various technical considerations, from experimental design through PCR performance and data analysis. Beyond the laboratory testing, several business components also have to be considered for a successful test launch and distribution. Each development step involves expenses, and to ensure cost effectiveness, a level of attention should be dedicated to streamlining workflows, optimizing resources, and creating profitability without compromising quality. The test needs to be adaptable to accommodate fluctuations in sample volumes, particularly during periods of seasonal demand spikes, as we just noted. This might include creating flexible workflows that are used in response to evolving throughput demands, while maintaining a desired turnaround time. For example, investing in an automated liquid handling instrument could boost sample processing, reduce reagent and consumables waste, and increase hands-on time for technicians. Such adjustments could ensure more scalable and efficient operations, leading to overall cost savings and more flexible work hours, while also enhancing throughput and your profits. Quality control is also a principal component to consider, as you must be able to deliver accurate and reliable results. Technical considerations for quality control include assay validation, staff competency, instrument maintenance, reagent storage, and proficiency testing. It is important to dedicate and mitigate potential sources of error and variability throughout the product development process to ensure quality. These measures involve establishing clear performance criteria and conducting studies to demonstrate the efficacy, reliability, and to align with regulatory requirements outlined by CLIA, CAP, and other laboratory agencies. Customer satisfaction involves anticipating the needs and preferences of your client by consistently delivering products and services to meet and hopefully exceed their expectations. A way to enhance customer experience with a GI test can be to prioritize convenience. This may begin by offering online bookings for appointments or prompt delivery of specimen kits, including the option for courier pickup if requested. Patient comfort for GI testing should also be considered and can be achieved through flexible sample collection options, such as fecal swabs and transport media, which could be collected at home, assisting with patient privacy while also increasing sample stability. Additionally, implementing secure and efficient sample transport mechanisms, such as prepaid shipping labels or conveniently located clinics, can streamline logistics and reduce burden on the patient, allowing them to focus on their health without unnecessary hassle. It is also beneficial to offer educational resources which explain the benefits of the testing being performed, FAQs, and easy access to customer support personnel. These items all contribute to building trust and confidence in your test and help the client to know that they are valued. And of course, it is always important to listen to feedback and resolve any issues promptly as they arise. The future of GI testing is promising, characterized by increased adoption of PCR-based methods in order to advance diagnostics. Focused panels are poised to dominate the testing landscape over comprehensive panels, given tightening restrictions on insurance coverage, reimbursement, and decisions on medical necessity. There's also increasing interest in detection of specific biomarkers linked with conditions like gastroenteritis, inflammatory bowel disease, and GI-related cancers. These areas are creating new market opportunities for laboratories to explore. Research into the GI microbiome is also a hot topic right now due to the desire to understand the gut in relation to immune function, disease states, and overall health. Now let's move on to a personal case study of our laboratories. PGL and PCL are two sister sites operating under common management. We aim to deliver top-tier laboratory services in general wellness and molecular specialty testing. Our goal is to ensure timely and meaningful results with a focus on access to care for all, with a special attention to our rural areas. We proudly service over 800 facilities throughout the southern United States and are pleased to be CLIA and CAP accredited laboratories. Our journey in GI testing implementation began by using a well-known moderate complexity syndromic testing platform. After about a year, we encountered challenges related to the low throughput and high cost of the pouch-based kits. And despite the simplicity of the laboratory protocol, manual setups consumed excessive time, and recurrent instrument issues led to a surge in samples requiring reprocessing. Additionally, we experienced extended instrument repair time and inadequate customer support, which were frustrating obstacles. These challenges contributed to increased staff hours, extended resulting time, doubled costs, and diminished our overall operational efficiency. The decline in our ability to deliver dependable testing services within our usual parameters began to adversely affect our clients and their satisfaction. We knew we had to make a change. So we began investigating alternative vendors with the mindset of creating a similar panel, but with higher scalability and lower cost per test. One vendor stood above the rest due to the amount of inventory pre-built assays and custom plate making capabilities. We turned our attention to Thermo Fisher Scientific in order to build a GI panel that better suited our company's needs. Starting from the experimental design stage, PGL initiated the development of a research-based comprehensive panel. Our aim was to add common pathogens while embracing the concept of bigger is better to compete with other panels that were currently on the market. However, we were mindful of needing future flexibility to add more specialized pathogens, which could set our test apart. For instance, we introduced the addition of 2 more strains of rotavirus, B and C, to differentiate our panel in response to client requests for less covered strains. During this time, Thermo Fisher Scientific was also in the process of developing a research-use-only enteric microbiota panel. Through participation in an early access program, PGL was able to collaborate with their R&D team in order to share data and optimize new assays before our product launch. Together, we gathered several weeks of comparison data in order to ensure accuracy and specificity of each assay in our lab. Ultimately, we successfully tailored our panel to mirror their pre-market GI panel, which is now commercially available as a pre-built product. PGL also focused on progression of quality aspects in training and performance and made significant improvements. We strengthened our team by hiring additional staff with expertise in high complexity testing workflows and molecular field experience. This strategic hiring decision helped in our ability to transition to more advanced protocols and successfully depart from previously moderate complexity tests. This expansion of our skilled workforce not only benefited our operational capabilities, but it also underscored our commitment to delivering top-tier lab services and strengthened our clients' trust. So here is a look at a recommended workflow for a GI PCR panel. First, we have sample receipt, which would include sample quality, intake, and pre-analytical steps. Then we move to RNA and DNA extraction. Our laboratories use the Kingfisher Flex system and use both the MagMax Microbiome Ultra and MagMax Prime line of reagents. Our panel goes through reverse transcription, so there's a pre-amplification step added here. Next, we move on to loading the DNA onto an open array chip with the AccuFill instrument. From there, real-time PCR is performed in order to detect pathogens present within the sample. This takes about 2.5 hours on the QuantStudio 12K Flex. Finally, there is data analysis, quality control, and LIS reporting. The open arrays can house up to 48 samples, and 4 open arrays can be run on a QuantStudio 12K at once. The runtime is the same whether there is 1 or 4 open arrays loaded. So this gives our laboratory a maximum throughput of 192 samples and a 5-hour runtime per instrument. Our current cost per test is around $50. In contrast, the moderate complexity test we previously used had a shorter overall process time of about 1.5 hours, but was only able to process 1 sample within that time frame, and it was completely dependent on the number of instrument modules that we purchased. The cost per test was around $130 for that system. I mentioned on the previous slide that PGL uses both the MagMax Microbiome and the Prime products. So why would we do that? Well, our lab began processing samples using the recommended enteric microbiota product line in alignment with typical user guides. But the workflow protocol was easy to follow when we had no issues with performance, but we did see a main difference in some steps throughout the workflow. The main difference between the GI and our other PCR test workflows was the need for an additional sample preparation step before DNA extraction. This step involved adding the sample to a bead tube or a bead plate, lysing with an additional buffer, and then moving forward with the rest of the method. This additional step only took around 10 minutes of processing time, but it required an additional instrument and additional consumables. While achieving success in our Louisiana market, we focused on launching the new panel at our PCL Houston laboratory site as well. And although everything was going smoothly, we wanted to find an alternative to the microbiome workflow to eliminate the need of the bead beading instrument at the PCL lab. We began exploring the possibility of omitting the bead beading step, considering that we only accept rectal and fecal swabs, which do not typically contain heavy debris like raw fecal samples would. Fortunately, we were able to shift our attention to the new MagMax Prime Viral Pathogen Kit, which was exactly what we needed to use in order to make these adjustments. After extensive comparisons and data correlation among extraction kits, we encountered one assay that required additional optimization. Out of the GI assays on our panel, rotavirus exhibited a lower limit of detection without the use of the bead beading step. This was puzzling to us at first, but with input from the Thermo Fisher R&D team, we devised a straightforward yet very clever solution. Since rotavirus is a double-stranded RNA virus, we added an additional 5-minute denaturation step prior to regular pre-amplification. With this small change, we saw an immediate improvement in rotavirus recovery levels. The MagMax Prime products eliminated the necessity for the bead plate, lysis buffer, an additional wash plate, and decreased our cost per test, reduced our reagent and consumables usage, and standardized methods across our laboratory sites without requiring the installation of an additional instrument. This also aligned our workflows to our other PCR infectious disease panels. Thermo Fisher offers multiple workflow solutions to seamlessly adapt, develop, and expand the laboratory clinical research testing capabilities in the GI space. They offer pre-built or custom panels, which are available as single tubes, array cards, open arrays, or 96 and 384 plates. Some examples of pre-made panels are listed here. All products are compatible with the Quant Studio family of instruments, which is a convenient and adaptable platform serving different levels of laboratory needs. As mentioned, PGL and PCL uses the Quant Studio 12K instrument, and we enjoy using the open array panels. For instance, our GI panel can be ran as one comprehensive test or as smaller focus panels such as parasite, foodborne illness, or E. coli specialty. The multiplexing ability of the open arrays has been extremely valuable, and it is best for our current processes. However, if we develop additional small specialty panels, we may consider transitioning to lower volume plates to keep costs down while still maximizing the number of samples per run. The Thermo Fisher pre-designed assays are versatile and can be used easily in different formats, and is still compatible with our instrumentation, which would make this transition very easy. In addition to GI application products, Thermo Fisher Scientific also offers a broad portfolio of solutions for other disease areas in research and diagnostics. You may find more information at the website listed here. As we bring the discussion of our GI PCR testing journey to a close, I'd like to acknowledge the importance of collaboration between client and industry. From the inception of panel design to meticulous validation and troubleshooting, Thermo Fisher Scientific has supported us every step of the way. Once available, we were able to purchase the pre-made enteric GI open array panel, and we have implemented custom open array panels for all of our other infectious disease PCR and research testing workflows for UTI, STI, wound, nail, and respiratory samples. We appreciate the large inventory of pre-designed assays, which allows us to adjust pathogens with market need and continue to follow our strategic goals. We have successfully continued to deliver quality results with a low turnaround time while enhancing customer service and streamlining our processes among two company sites. PGL and PCL are grateful for the guidance and resources available through Thermo Fisher Scientific and look forward to achieving new company milestones together. Thank you so much for listening to me do this presentation today. If you have any direct inquiries, please contact me directly at my email here or by phone, and please also visit us at our company website. Thank you.
Rachel, thank you for that excellent presentation. It is now time for our live Q&A portion of our webinar. Now to our audience, if you have any questions you would like to ask and you haven't already done so, do so now. Just type them into the Ask a Question box and click Submit. We will answer as many of their questions as we have time for. So Rachel, we've got a lot of questions already coming in. I'm just going to dive right in. Let's start with this one. What are some key challenges laboratories face in implementing new molecular panels, and how did you navigate these challenges during the panel launch phase?
Okay, yeah, I think a key challenge when introducing any new test is having solid training, communication, and education among all of your departments within the company. So molecular testing is especially complex, which means that there are additional stringent quality measures that have to be met and maintained, and the results may be a little bit more difficult to interpret at first. So the lab staff will receive the majority of the in-depth and hands-on training. However, you still have to have a confident sales team, revenue cycle department, quality assurance team, and also have confident customer service agents in order to really bring the company together and have a successful product launch. So I think that is a key challenge. The other key challenge when launching a brand new panel is, how is this test going to be received by the market? You've done all this work in order to get it ready and launch. So now you're expecting that you would have, some successful amount of volume. So in order to kind of forecast different volumes, you could look into historical metrics for performance of similar products in your region. And also, it's very important to just engage your current client base and listen to their feedback and assess the market competition and play out best case, worst case scenarios within your company, and just really rely on that customer feedback.
Now, Rachel, how do you anticipate evolving needs in the market and pathogen relevance when designing tests on GI panels?
Sure. So as I kind of alluded to just a moment ago, I like to work really directly with our sales teams in order to gather that really important client feedback and listen to their requests for new product development. So I make sure to do that, and we have large meetings every quarter in order to capture the needs of our current clients and our current market. Otherwise, I like to monitor positivity rates and both internally and then also compare them to state health departments and the NIH. I also search for emerging pathogens by looking through literature publications on PubMed, through attending additional webinars, and then also like to read news articles published from the CDC.
Now, Rachel, we're getting a lot of questions coming in about optimization of assays. How do you make sure the pathogen assays are optimized for your test?
Oh, goodness. I would consider an assay to be optimized when your levels of detection, specificity, accuracy, and precision not only matches, but exceeds the quality measures that are outlined from your laboratory regulatory body. And you also have to have both consistent and reproducible correlation between clinical research samples and proficiency testing samples. So I always recommend using pre-designed assays from industry vendors, or at least using their design platforms for help if you want to create your own custom assay, because there are a lot of difficulties when trying to create a primer probe design from the very beginning.
Thank you. And we have time for one more question, and I'm going to hit the workflow topic here. How do you make enhancements to your workflows?
Sure. So when I think of enhancements to workflows, I think of three basic things. I want to make sure that I look at efficiency, accuracy, and consistency. So one easy enhancement that we're looking into doing here at PGL and PCL actually is to add automation or liquid handling instruments to our current workflows. So this was going to help us to cut down on staff hands-on time and help us to reduce our reagent waste and the associated costs. Another way to enhance a workflow would be to purchase pre-mixed reagents that could minimize preparation time, help monitor inventory, and also monitor shelf life.
Rachel, thank you so much for your time today and for your valuable research. Do you have any final comments for our audience?
I just want to thank everyone again for this wonderful opportunity and for listening to my presentation today. And just to remind everyone to please check out our company website and to reach out to me directly with any further inquiries.
Excellent. Thank you. And I do want to also thank our sponsor, Thermo Fisher Scientific, and LabRoots for helping bring this educational webcast to all of you. That's all for now. Thank you again for joining us. Rachel, again, thank you for your time and your valuable information. Take care, everyone.
Thank you so much.